Actually, the nuclear chemistry is just very similar to regular chemical reactions. In a regular chemical reaction, so we say that the reactive reactants can do the product. The non-reactive one or the stable one cannot do. Right? For example, hydrochloric acid can react with sodium hydroxide to make salt and water. Hydrochloric acid and sodium hydroxide are strong reagents, strong acid, strong base, so they can do reaction. The stable reactants like calcium carbonate or limestone and water, they don't do reaction because they're stable, right? In nuclear chemistry, the stable, we talk about the nucleus, the stability of nucleus. For example, here, so we have carbon 12, which is a regular carbon, normal carbon, the highest percent abundant, and followed by carbon 13, so the second highest. These two exist in nature. All right, their nuclei are stable enough to exist in nature, and we call them, so they are non-radioactive. They don't go the decay. Now, carbon 14, this guy have way too many neutrons. Okay, so since the nucleus is not stable, so it undergoes spontaneous radioactive decay to form a more stable or non-radioactive nucleus, which is in this case nitrogen 14. Okay, and the electron comes out. Before we go further, so what type of radiation is it? Anyone remember? Look at that. Look at that. A beta decay, a beta radiation. So that's electron. Okay. So now the question is, who is radioactive or not? Okay. So and how do we know? If you look at the periodic table, so one more time, these are non-radioactive elements. Okay. The except we have technetium 98 and promethium 145. These two are synthetic elements. Their nuclei are not stable, so they are radioactive. Okay. The heaviest and the last non-radioactive element is bismuth 209. Anything above bismuth are radioactive. All right. Just for your information, the first 92 elements are naturally occurring. Okay, so up to everything up to uranium 92, uranium 238. So they are naturally occurring, but anything above 83 are radioactive elements. Okay, plus technetium and primordium. All right. So when I say these elements are non-radioactive, I'm just talking about like carbon 12, nitrogen 14, oxygen 16, fluorine 19. If you look at, but they are non-radioactive, but their isotopes are not. Okay, so carbon 12 and carbon 13 are non-radioactive, but carbon 14 is radioactive. Fluorine 19, regular fluorine, is non-radioactive, but fluorine 18 is radioactive. Okay. Now, the question is, how do we know which element or which isotope is radioactive? Well, people have done some study about it. Okay, so let's take a look at the density of the nucleus.